Hello friends and hello student. My name is Ashok Sigala. In this session, we learn the octal to hexadecimal number in C language. So first, I share my laptop screen and fix the position here so you can watch better my video lecture. And here, Turbo C++, I double click and take some process. And now, yes, is open Alt F file menu, take new file, and here our goal write a program to convert octal to hexadecimal number. So yes, here we can learn two number system. So first we can say that that is octal, so that is 0 to 7, so that is a base of 8, and hexadecimal, so 0 to 9 and A to F, that alphabet, so that is a 16 base. So now we can better understand through the paperwork, or we can say that one example, so like 565, yes, and that is we can say that octal number, and now we can convert an equivalent to the hexadecimal number. So step by step we can understand. So first step, we can convert octal number into binary number. So yes, here I write 5, then you can say that 6 and again 5. So that is like 101. You have to know that is a binary of 5 number. Yes, and now 110. So that is a binary of 6, and again 101. So that is a you can say that binary. Now step number 2, and we can extract extract 4 bits in a group. So we can define 4 uh, group in bits. So here that 101 is there, but 0 we have to take from 6, and here remaining 1 and 1 and 0 extract from 5, and here remaining only 1, so I provide 30. So that is a 4 group, means 4 bits we have to define to our group. And now step number 3, so we can say that hexa, yes, decimal number to given each, yes, group. So we can give each group to is appropriate that hexadecimal number. So here is a 1, this group, because only 1 is there, and here is a 7 because triple 1 is there, and here you have to know 101, so that is a 5. So now that perfectly, and now step number 4, that we can say that hexadecimal number. So that is a binary to hexa. So we can say that our 101, then 110 and 101. So that binary to 175. So that is our hexadecimal number, binary to hexa. So yes, that perfectly we have to find. So here we can say that 175 is our answer. So that is a perfectly, I think you have to understand. And now we can apply to this our logic. So I give multi comment line, and now we can start to our C logic. So first is a link section, our header file. So that is a standard input output dot h, and then conio console input output dot h, and we can also use string function. So I can include string.h header file. Here 3 header file is required. Now void main, yes, now main function, and we can define that is our octal, so oct underscore value, and that is a 1D array. So you have to know that is a 0 to 7. So 0 is 0 binary, then 1, then 10, then we can send 11, then 100, 101, then yes, 110, and then last 111. So yes, let us check. So we can say that 0, 1, 2, 3, 4, 5, 6, and 7. Yes, that perfectly. So yes, I also defined rem reminder that one integer variable. And now we can take long, that is 2 times long, and we can define tull, yes, and temp underscore OCT. So we can store our original in temp octal, and then we can take as a binary, so that is 0, and position, so that assigned to 1. So yes, that perfectly. And now character hex, that we can define 65, and that assign character 1D array blind. And now clear the screen. So yes, that is input, process, and output. So first step is input, divide and conquer any definition in C language. So first, that is input. So enter one, you can say that octal number. That is our input. So I can scan, yes. So percentage, which formatting symbol used for long integers? So LLD, that is our formatting symbol, and OCT, that is our variable. So first step, we can take temp OCT equal to our OCT original octal number. And now that is you have to know, that is a while loop is the best choice for number programming. So here we can use temp octal, not original or octal number. So that is a greater than 0. So we can take first as reminder. So we can say that temp underscore OCT and modulo, we can separate to our digit. And now we can take as binary, so we can use octal underscore value, that is our 1D array, and pass to our reminder as a index, and then multiply, that is our position, and then plus that binary number. So let us check. And then temp underscore OCT divide equal to 10. Yes, and position. So P multiply equal to, yes, that is compound. Here I also use compound, divide or equal to. So 1000. Yes, so there are 4 statements. So that is our logic. So I write in comment line. So here first step, we can convert octal number into binary number. That is our first step. So yes, here we can look very easily. So we can also trace in watch and output window. So first we can take reminder, and that reminder we can go in our, that is 1D array 0 to 7, that is a binary of octal number, and then we can divide, so that is getting new number, and 1000. Why? Because that taking the position. And here I write one full statement. So P equal to P multiply 1000. So that is a full form. So that is a compound assignment operator. Yes, and now we can again I comment line. So convert now the binary to hexa decimal number. So that is our second step. So again, I take as a while loop, yes, and that we can say that binary binary is a greater than 0. So yes, so that binary number first we can use as a octal number. Now octal number is converting binary, so binary is greater than 0. And now again I use reminder and binary and modulo, so that is at 10,000. So we can give like a 4 digit group. So we can separate, that is a modulo 10,000, 40. So 10,000 we have to modulo. So that perfectly we can take our 4 bits output. And now we can take as a switch case, yes, and pass the reminder. And now we can take as a 16 case, because that is a hexadecimal. So we can say that 0, and that we can use string handling function strcat, string concat, and use our that is hex, that is 1D array, and store, that is 0. And now that first case, and now we can break. So I can already include string.h header file, string concat. So now I can copy and paste, control insert and shift insert. So 16 case we have to take. So yes, let us take one by one. So here again 1. So here we can store as a 1. Now we can say that 10. So here 2 digit, and now here that is a, we can say that 11. So digit 3, then now 4. So here is a 100, yes, and then 5. So 5 you have to know, we already in our paperwork 101, that is a hexa. And now we can say that 6. So we can say that 1 1, yes. So 6 is a hexadecimal 1 1, and now triple 1. So that is a binary of number that's 7, and now I take as 8. So that is a 1000, and now that I take as 9 our digit. So that is a 1001. Yes. So that is a perfectly. I take as a break keyword, so some shifting, because that proper looking is better. So our case, that constant value is a now not one, first is a 2, case is 1 digit, now 2 digit and 3, and now 4 digit our case, and now that is a 101. So that is a what character, what digit. So here not any digit but alpha capital A. Yes. And now again that is a 1011. So that is a capital B. Yes, I follow the table. So that is a 16. We can go. Yes, here capital A, then B, C, D, E. So that is a F. Yes, here I go in F. So let us check capital C. Yes, and that is a hexa is a so 1100. So and now that capital D. So we can say that capital D hexa is a 10101. Yes, that capital D, and now cap E. Yes, so we can say that E is a, yes, that is now 1110, and last is a F. So that is a, all R is 141. So that perfectly. So we can take as a 16 case. Yes, 0 to 9. So that is a 10, and A to F. So that is a perfectly we can take as a 16 case. Okay. Now, yes, in the while loop we can take as again to our use as a um, division. So binary that divide equal to 10,000. So because that is a group of 4 bits, so we can divide in the 10,000. Yes, and now that we can complete to our logic. And now after the while loop, yes, here our while loop is closed. So yes, that we can match that brace, and here we can str rev string reverse. I can pass hex, and now we can print to our number. So first we can say that octal number. So we can say that percentage LLD to hexa decimal number is, and percentage s, because that is a 1D array, string character array, because alpha is a hexadecimal is a alpha and digit both combination. So here I print our octal because that we can store, and now here I print hex at our 1D array, and then get ch. Yes, perfectly. So now I can save this file. So we can say that octal underscore hex dot c. Yes, that perfectly. And now I can compile. Yes, there is no any error. So perfectly. So yes, let us check. So we can say that here is perfectly, or we can verify any mistake is not there. So I think no any, but we can confirm. So 0, 1, then we can say that 2, 3, 4, 5, and 6, and then that is a 7. So I think that perfectly, and reminder. So long, yes. Why I taking? Because that we have to take as watch window. So that is a our normal integer data type that range positive 32,767. But here that is more. So I take as a long because binary, and that position is at 1 lakh, 10 lakh, something that position is go. So we can check in watch window. So that is a we can take as a long integer. So yes, that is in your mind question. So, and why I divide the 10,000 and 1,000. So we can give that answer also in watch window. So yes, I think all are well. So let us check. 10116 case. Yes, any 10123. Yes, 4, 5, 6, 7, 8, 9, 10. Means F, capital A, B, C, D, E, and F. Yes, perfectly, no any mistakes. So let us check. I compile, and yes, we can give like our paperwork. So 565, 565. So you can look that perfectly 175. That is our answer. We have to sure because we have to take as a paperwork. So yes, let us check this answer in watch window. So alter W, and I take as watch, yes, and alter W and output. So yes, you can see our previously output store in the output window. And now I can set to watch window and our variable. Yes, here we can use as mm, all variable we have to set. So first I go in the variable list. Yes, here. So we can set all variable in our watch window. So first our array octal value. So 0 to 7, that binary we have to store. Then octal original number. Then temp underscore OCT octal variable. Then binary is there. I go the declaration syntax. Yes, and then hex, and that is a 1D array. So here we can pass as a reminder. Yes, and also we can take as a octal underscore value, and in the bracket also we can take, yes, here in first that I take as a reminder. So yes, octal underscore value and then reminder. So we can see that all variable. Now I can start our watch. So alter R, you have to not trace into F7 function key I press. So you can look all, yes, our uh, all are set. Yes, binary and position taking 0 and 1 that assign that hexa character 1D array assign null. Yes, and clear the screen. Our output window is clear, and now message enter one octal number. Yes, so here I take 565. That is our paperwork, so we can easily understand, and that store in temp octal. So here you can see let garbage value now gone, and yes, both are same, and octal greater than 0. Yes, then reminder. So yes, you can also take as reminder separately. So rem, so we can see easily. Yes, now that also take garbage, but now that gone. So 5 store. Yes, 5 is modulo 10, so that separate, and that take position of reminder 5 to our index. So book index start with 0. So actually that is a here we can say that 0, 1, 2, 3, 4, and 5. So 101, that is binary store. Yes, here look in the binary that variable bin. So yes, that perfectly, and bin is first that initial 0, and that so only 101. Yes, and now divide. So that is taking 56. Yes, here that temp, yes, temp octal, you can say that 56, and then taking 1000. Yes, that taking our position. So p initially 1. So here multiplication operation, so I take as a p1, otherwise all are 0. So multiplication, whenever maths rules, you have to divide any number to 0. So all are multiplication operation 0. So I assign as a 1 to position. So now look that P is a 1000 directly. Yes. And now again while loop is true because that is a 56. Yes. and separate, that is store in 6. Yes, our rem variable that store 6, and now that 6 position, so that is a 6 digit that binary, so that is a, we can say that 110. You can look here 110, and concat means store in our previously binary value. So we can multiply. Yes, here taking again division operation. So that is a 5 only, that octal, temp octal, and then taking position. So 1000. So P is a look here out of range binary and means normal integer data type. So I take the, I previously told I take the answer in the watch window. So here that answer. Here, why I taking the long integer? So your look normal integer data type is not sufficient of range. Here, like 10 lakh store in position. So that is a very go long range. So I take as a long integer. So that is a sufficient to store that value. Otherwise, they're taking as a garbage value. So yes, last time while loop is true, yes, and now 5 separate again, that taking 101 that position, and here look that our answer, our paperwork 101 110 101. Yes, so 5, then 6, then 5, that binary number convert octal to binary. Yes, that divide by temp octal 10, so that is a now 0, and then here look that position is very uh, larger normal or integer data type, and now while loop is false because temp is 0, temp octal 0, so that is a binary greater than 0. Now second step, convert binary to hexadecimal number. So yes, here I take as a 4 bit, so that is we define the 4 bit separation. So look that modulo rem store, now you can look 101, so directly go in the or case 101. So that is a 5, yes, digit of 5, and that concat in hex character 1D array. So that is a 5, yes, overhead that is, and now back again that divide. So that binary number divide by 10,000. So yes, here 101 is gone directly. So I can divide and modulo 10,000. So now you can understand what is required of the divide and modulo of 10,000. And here is a 1,000 and here is a 10,000. So now again that while loop is complete. Yes, now modulo, so separate, that is reminder 111. So that is a binary of 7. Yes, here you can look that is a 7 hex store. Yes. Now break again that divide. So only remaining 1 because 4. So only 1 is remaining greater than, yes, that only. So reminder, yes, 1, and that go in 1 months. 1 case number 1 means, so and concat 1, so that is a break, and then 0, so that is a while loop is now false, and that reverse. So you can look first that store is a in means reverse order, because we have to first that find as a 5, then 7 and 1, now in reverse order. So 175, so that I reverse, and now so str string reverse, so because that is a 1D array, and hexa is a alpha and digit both combination. So now you can look our output is print perfectly. So yes, that I think, I hope you can understand and enjoy. Yes, so now let us take some more, we can compile and watch other number also. So now I complete this watch window. Yes, and can take as so here our program is completed. Yes, and you can see our output. Yes, perfectly. So now, yes, I think all are well. And now I press F7 function key. So that watch is complete. Yes, and now again I means run. So look now, yes, here I pass like 123, 123. Yes, so that is a 53, that hexadecimal number. And also again I run. So yes, that full screen and run. So you can look like 3 pi 4. So 3 5 4. So that is the EC. So yes, that is both is alpha. So that all are perfectly well. So you can take any octal number. Yes, that is here we can take care as passing as an octal number, not greater than digit of 9 or 8. So that you have to understand. So then and then that getting the hexadecimal number value. So yes, I hope you can understand and enjoy this session. So write this octal to hexadecimal conversion program in your C notebook. Here very interesting and step by step. So I first take as a paperwork, 4 step I explain and very simple way to explain to you. So I hope you can understand. And yes, a very simple logic. So first step we can take octal to binary. So we can already in paperwork, and then we can just here I think we can store yes 0 to 7, that is a binary of that 0 to 7 digit, and then apply to our work. So that is very important. So very simple. And like we can improve here, yes I take as a binary. So here like we can plus equal, that is a compound. Let us check that work perfectly or not. I compile again and run. So I testing 565. Yes, there is no problem. So that is a why we can write 2 times. So yes, here perfectly that short technique, compound assignment operator. So that is an improvement some. Otherwise, all are where here no any chance, no any reduce our variable, no any statement we have to remove. All are well. So yes, now I think perfectly we have to, yes, all our 16 case is required here. Very long here. You can look. So 0 to 9 and A to F, all I equivalent binary that case we have to define, and then we can get. And here very important, we can divide and modulo also. In previously we can take as reminder is a modulo operator 10,000. So we can group of 4 digits. So I take as a divide and module as a 10,000, and string reverse, that is also important. So we can directly not print, otherwise that if I write in comment line in this and let us check what happened. So that is a not like 565. I also testing. So you can look 571. So that is a not equivalent that hexadecimal number. So that is a very important. We can use as a string reverse. Yes. So because that is a character 1D array. So yes, so you can all directly apply the string. So here in this program, I use two string concat in every case. Yes, here we can use as a string concatenation and string reverse REV. So string reverse, two string handling function we have to use in this logic. So all are well. Now I close this file to FT, close, yes, and I think, and any question regarding this definition or any concept of this, you cannot understand of any this while loop of logic or in second while loop of this logic 16 case. So you can write in comment section. I give the definitely answer to you. And now I can close, yes, first our file alter F3, watch an output window and quit. So subscribe my channel Ashok Sijal Academy, press the bell icon to never miss any update. Thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.